Thank you for coming today. I'm going to talk to you about why us United States needs to implement the metric system as our standard measuring unit. And I know every time someone mentions this, everybody starts grumbling and says, well, it's perfectly fine the way it is. We don't need to change it. Our system's been around, in some form since, the beginning of the country. But the problem is, the current system uses all these different combinations of measurements that don't have a uniform conversion. 3 feet equal a yard, all this 12 inches equal a foot. They don't match up. It's very hard. You have to memorize it. It's not an easy conversion factor. And another thing is, the United States is one of only 3 countries and the only industrialized nation in the world that does not use the metric system. The other 2 are Liberia and Myanmar. And Myanmar already is almost done implementing it. They just basically have to sign the paperwork and they're done. And Liberia has been using the metric system for a while. They just haven't made it law. And so, we're pretty much the only country in the world that doesn't like to use the metric system. And I believe, us as a country standing alone against the world, with this resistance against the metric system is a bad thing. And this unwillingness to change will, and has in the past, caused problems. Probably the most prominent and expensive example of this problem was the Mars climate orbiter. It had originally launched from Florida in December of 1998, and it was being sent to Mars. It was going to go into controlled orbit decay, test sensor deployment, and gather specimens and data, and for further projects. And the actual orbiter insertion was planned for September 23rd of 1999. And when it was coming close to Mars, they were getting ready to do prep insertion data, and they found that its trajectory was coming in at about 110 kilometers preapsis into the planet, which is the lowest point of the arc they were aiming for. And actually, they originally wanted 226 kilometers. So they went, okay, well, something weird happened, so we redid the calculations, sent the data. It did its little burn, and about 4 minutes later, they lost signal, which was over a minute earlier than expected. But then after 2 days of never getting a new signal, they started doing an investigation. Well, in the report from the incident, from the Mishap Investigation Board, it was determined that the main cause of the accident was the lander was actually getting data in pounds of force per second instead of newtons per second, which was the desired number. And this created a trajectory error, which was off by a factor of 4.45, which actually 1 pound of force is equal to 4.45 newtons. So they were able to trace that back. And this created a very steep approach angle, which caused the satellite to be lost. And they determined that actually the orbiter came within 57 kilometers of the planet, and 80 kilometers is actually the lowest survivable altitude for the first approach. And so they lost the satellite because of this. And and since the commands at the time, you try to talk to satellite way off there in space, they're not instantaneous. So you have to do the measurements here on Earth. And Lockheed Martin was in charge of the program that did it, and they did everything in U.S. standards. So they were getting a number, thinking it was pounds force. They did their calculation, give it back in pounds force. NASA had no idea, and so the satellite went off course and they lost it. Another incident happened. It was in Tokyo Disneyland. The Space Mountain roller coaster coming in the station, the axle broke, and the train derailed, and luckily no one was hurt. And what they found was when it was originally built, they took the U.S. plans, U.S. measurements, and converted it and built a roller coaster, which was no problem. But when it came to the replacement time for axles, they went to the wrong drawings. They got the original drawings, and not realizing it, and ordered the axles built, and the axles were built 0.9 millimeters thinner than the actual axle should have been, which ended up creating a gap between the axle and the bearing, which created a fault, and then it broke. And with this, and this was one of those things that, someone like, perfect example is these bolts right here. Ignoring the length, you sit there and look at these, you hold them, you would think these things are almost identical. The difference between the diameter of these bolts is 0.9 millimeters. The fault that axle, the 2 axles were made. And you wouldn't notice the difference, and you say these should work. But in the tolerances they needed with the bearings, that 0.9 is, I don't want to use catastrophic, but it is. It's not designed to do that. And it's not just mechanical issues that not using the metric system can cause. By not using the metric system, children medication prescription can have complications because of, improper dosage. Because many people confuse teaspoon and tablespoon. I mean, I can remember many times to where, you sit there and stare at the measurements and figure out which one you're supposed to be using. And actually, there was a study that said 70,000 children a year go to the emergency room because of accidental medication overdose. And an alert put out by the Joint Commission, which is a group that accredits all the health organizations in the United States, pointed out that 32.4% of pediatric errors in the operating room were involved to improper dose quantity, compared to 14.6 for adults. And then another analysis done by the official journal of the American Academy of Pediatrics concluded that a milliliter only standard was needed to reduce the medication errors, because they found that 39.4% of parents made an error in measuring their intended dose. And these items I mentioned here are just examples, but Emil Vlad wrote a journal article pointing out that, all these incidents you hear about, for every one or two that you hear about, there's probably another major one or up to 300 minor ones we never hear about, over incidents where, having to worry about conversion from standard to metric caused a problem. In conclusion, we see how simple errors have caused drastic results. Medication errors, faulty machine work and stuff like that. But by implementing the metric system, this would put us on par with the rest of the world, and then making passing of data easier, less chance of problems causing between us. And I mean, most people know the metric system's already in curriculum. You learn it growing up, but it's just not enforced. And so we just need to put a little bit of emphasis and usage in it. I mean, the key is, it's a simpler system. Everything is, factor of 10, conversions done by just moving the decimal point, so it's pretty simple. And it's much simpler and easier to remember than the U.S. system. And this is especially helpful for immigrants coming to this country. They've had problems with truck drivers coming in. They know their truck's 2.5 meters tall. They come around a corner, there's a bridge in feet, and most people, even you guys, probably have trouble trying to convert that over pretty quick before you're going to hit the bridge. And so, this is something that we need to worry about. And Ron Villarreal mentioned an article in the International Business Times about how many companies that work overseas have already started adopting the metric system. A perfect example is actually this water bottle. If you look on here, it says 16.9 ounces. Most people think that, they just throw a dartboard to pick that number. But your water out here at the end, 500 milliliters. This is a half-liter bottle. And they did the same thing with this. You'd think, oh, this must be some new gallon design to make it easier to use. Nope, 3 liters. So, they make one design for one bottle for all over the world. And, the government needs to get more involved. I mean, they already tried to pass some laws that didn't follow. And, the fact that most measuring device in the U.S. has standard and metric is part of those laws. But they never enforce it. And so we just need to keep moving on. Like I mentioned before, the Mars Orbiter, that mission cost over $327 million. And we got no data, no information out of it. I mean, we need to spend the time and money to implement the metric system in the United States, because we need to prevent future possible loss of life and money instead of holding on to an inefficient and antiquated system that should be part of our past. Thank you.